I'm talking about the types in TypeScript, the type system, which the TypeScript has got a very sophisticated type system, which I find quite ironic, given that it's based on JavaScript, but it's quite an interesting contrast. So the reason that you're seeing the keynote in all its glory is that I'll be flicking over to code examples as well to try and illustrate things. Right, okay. So I've used 3 books as a kind of inspiration for this talk. Interestingly, none of them are to do with TypeScript. Domain Modeling Made Functional is in F#, is a very easy book to read, has lots of pictures, and has a fantastic introduction to DDD. Functional Reactive Domain Modeling is a Scala book, is very complete, but very sophisticated to kind of get into. Category Theory for Programmers is a Haskell book and will really bake your noodle. Choosing it as my holiday read was not a great idea. Any questions so far? Okay. So what are types? A type is essentially a set of values. So the bool type is the set of true and false. The number type is the set of numbers from minus huge number to positive number. And what that gives you is it gives you a constraint, and essentially it enables you to make illegal states unrepresentable. So for example, a bool can't be true, false, 9, for example. So we'll be looking at that, and we'll be looking at how we can push that further and make states illegal in a domain context. In the context of TypeScript, types are erasing, which means that once it's compiled down to JavaScript, there's no trace of it. Also, a type can be literal, which is quite mad, but yeah, we'll see how that's actually really interesting. Any questions? Cool. So what are not classes, types? So classes and types are not the same thing. So classes in your kind of classical OO kind of paradigm will model state and behavior. Types just model states. Also, within the context of TypeScript, they're not erasing. Types exist in the value space as well as the type space, i.e. within your JavaScript code, you can reference classes. Interfaces are slightly different. Interfaces are pretty much equivalent to types in what they do and how they act. But in my view, at least, they are philosophically different. They model the contracts that you might have between classes or libraries or APIs. Okay, so TypeScript. So what does TypeScript actually look like? Let's have a look. So this is TypeScript. As you can see, this is just bog standard JavaScript. However, we've got some tests here. The tests are failing, but the code itself looks fine. So are there any questions around this so far, what I have here? Okay. So back to TypeScript itself. So you have what's called a type alias, which uses the type keyword. And basically, this is just where you would define your type. So you can either alias it directly, say you have a type A is just a type of string, or you can make it more complex. So how might this look? So I've extracted the type from here, as we can see here, and straight away we can see that we have compile errors. Why would that be? So we're also seeing here that, so for example, here we've got type credit card is not assignable to the type credit card or check. So when we spoke about literal types, we can have a type of an actual string. So the compiler itself is telling me that I have mistyped my string. Let's try and make that correct. We have another compile error here. It's telling me that it's expecting a string, but actually it's a number. So again, this is telling me that I've got this wrong. All of a sudden, we are seeing that this is looking a lot better. And then if I save that, will we get test passing? I don't know. Should do. Aha. So, and also this is possibly an undefined. So here we have this question mark. We're saying, as you can see from the definition, we're saying that this might be a string or it might not. This is something that we'll come to later, but to force this, we can put a pling here and here and here. This is telling the compiler that we know better, and we're actually saying we have something in here, even if we don't. That's actually not so great, so it'd be nice if we could get rid of that. Any questions so far? Okay. So given our basic types, we've got a thing called type composition. So type composition is where we blend our types together. So we either have intersections, which is when we add the types together, which is kind of a bit like how in OO, where you might inherit one thing from another, but really all it does is it mashes them together. And also unions, where you can say one thing is this or it's another, but it's not the same. We also have type narrowing as well. Bear that in mind. That's interesting. We'll come back to that. So how might this look then if we were to, for example, use type unions? So we have our union here. So what we've said is our payment type, which we had back here, can actually be a credit card method or a check method. This means that here and here, we no longer make these optional. So we are forcing the type system to confirm that we can never have a null if you can't actually have an undefined in here. The compiler won't let us. So, okay, so now that we have that, you can see that we have another compile error here. So what that's telling us is actually, again, if we refer back to here where we had our account, that actually, if we come back again, that doesn't relate to our credit card payment. It relates to the check payment. So as you can see, we're refining our set of types, and as we go through that, the things that we're allowed to do become constrained, and it forces us down a path of correctness. So if we were to change this, we could have a card number, and then it becomes a lot happier. And do our test pass yet? No, so we still don't have passing tests, but we do have compiling tests. So let's see if we can make this a bit more interesting. So I want to take a little bit of a diversion here. So we spoke about just now about the optional types and how it's a good thing that we can get rid of them. So here you can see our type string. It's not possible within the compiler to have an undefined. If we were to make a union type with the undefined, which is actually the same as saying string question mark, we would be able to set this as undefined. This is known as the billion-dollar mistake, because when null, which is how it was originally formulated, null was first invented way back when. It's estimated that a conservative figure of the introduction of null has cost $1 billion at least in computing errors since its invention. Any questions yet?
Yeah, there's one in the chat from, I don't know if that's supposed to say Crooney or C. Rooney, but I assume it's the latter. Was the account error detected automatically inside that switch statement?
So I'm assuming that you mean this one here. So from our original TypeScript, I put it in here as a deliberate error. When we got to here, when we'd refined our domain model, the compiler then told us that actually we'd made a typo when we put a wrong property name in there. Does that answer the question? Have I understood that correctly?
Yeah, that looks to have done it.
Right. Okay. So how does equivalence work in types? So TypeScript uses a technique called structural typing. So if string A and string B look the same as they do here, then TypeScript will say that they are the same. Now, this is different to say something like Java or C#, where the equivalence is all about the name. So if this was defined in C#, type A and type B would not be equivalent. That leads to some interesting funnies. So say, for example, here, we are seeing a failing test, but we don't know why that is. The code looks fine, it's compiling fine. Why would that be? As you can see here, if you go back to what we spoke about earlier about the type aliasing, we've created an alias of our credit card number, our account number. So it should be looking at that, but according to our test, we've got them back to front. Why isn't it picking that up? And the answer is because of this structural typing. They're all strings. So what can we do about that? Let's have a look here. So we have this concept called tagged types. So if we look at this here, going back to what we were talking about, how a type can also be a literal number or string, we are taking advantage of that here. So we have this tag, which is a generic, which I will briefly speak about in a sec. So what we can say now is our credit card number is a string and an intersection of a tag of this type here. And an account number is a string and the tag of this type here. And all of a sudden, you will see that we've got compile errors here. And so this, you can see here, the compiler is actually telling us that we've got our AC and our SC the wrong way around. So let's see what happens if we put them back the right way. And all of a sudden, this is actually compiling. So when we talk about anti-patterns such as primitive obsession, this is a really good method to kind of make that primitive obsession kind of visible and surface it and be able to model your domain in such a way that you can still have primitive types, but you still rely on the type system to make sure that you haven't mixed things up. Any questions with that? Okay. So.
Oh, sorry, Mike. Yes? Sorry for the delayed chiming
no problem.
in. So Adrian has a question. Is the type property itself special, or could it be called payment type and still work?
Sorry, could you repeat that?
Sure. So verbatim, it says, is the type property special, or could it be called payment type and still work? So I don't think type as a property name is reserved, but maybe you could elaborate on that.
Oh, right. Yes. So so when you have a union type, such as you have here, TypeScript will look at the two classes that you have here, and it will look to see if you have fields in here which it can use to differentiate between the two types. So it will say that you've got a type here and a type here. So those fields are the same, but this is that string and that is that string. So it will say, right, okay, I've recognized the same field numbers, they've got different values. Therefore, I can use that to differentiate between types. And type isn't a reserved, in this case, type isn't a reserved word. It could be payment type, it could be foobar, it could be anything.
Cool.
Okay.
Right.
So generic types. So I'm only going to touch briefly on generics because they're like a whole topic in themselves. I've got like a small example here. So you can, so the syntax is slightly different to say what you might know in say Java or C#. You have this extends keyword, but yeah, So if you put things in the angle brackets, that kind of denotes that it's a generic type. You can also say here that it extends B so that you can say whichever type that I put into this generic function f, it always has to be based on my type B here. So if it has a B, I know that it's always going to have these properties here. And we've actually used that extends here. So what we're doing is we're saying this tag, whatever I put in the concrete implementation of this tag, it's always going to be based on a string. Incidentally, I've called it an interface here rather than using type, purely because I want to get across that this is kind of like a contract rather than a thing. So that's why I've used interface rather than type to kind of flag up that difference. Does that make sense? Any questions on generics? Okay. So I've jumped ahead of myself slightly, but yeah, this is where I kind of pull the tag types out. There is actually a pretty cool library that you can use on TypeScript called Tag Hero. So I don't know if anyone's ever had a play with Idris, which is based on Haskell, but is even more ivory tower. But that has the concept of dependent types. So a dependent type is a type that actually has constraints based on values as well as other types. So for example, here in this example that we've got, we can say that our type of Gmail is a string, but in the type system, so at compile time, we can guarantee that it always ends with a @gmail.com. It's always at least 15 characters long, and it's never more than 200 characters big, which in terms of validating your data and defensive coding and not having to have a whole bunch of code to test for exceptions or whatever is incredibly powerful. So let's have a look at that. I'll just make sure that I haven't got my, yeah, here we go. So let's just have a look. So, so I've imported from Tag Hero. In comparison to this, to my original definition of the credit card number, the account number, and the sort code, they're a string. They are also digits, and they also have a size. So what I'm saying, at compile time, I'm guaranteeing that my credit card number is always a size 16. Account number always has 8 digits. The sort code always has 6 digits. If it doesn't, it won't compile. And let's see how we can show that. So in here, I've just assigned them as strings as normal. That's fine because this is a typed string. Here, you can see that the type system is telling us that that it's a string and it's not a credit card number. So we need a way of narrowing. So I spoke about narrowing earlier, and here's one that I've prepared earlier. So you can see here, we have our string, But when we get to here, we have our type has changed. So what narrowing does is it's a way of telling the compiler that the type of the instance that you're using, you're constraining it down further and further. So in here, we have just a normal string. So this is digits is a tag hero library, but it's a modifier that if it passes, so if it gets past this, the compiler knows that this value is also a string and it also has digits. Similarly, when we get here, the compiler knows if we get past this, the value is digits and has a size 16. Therefore, if we've got past this throw, the compiler knows that this has to have been narrowed down to have all of those intersections. Similarly, we've got a separate thing here and a separate thing here where we validate our account number and our sort code. Now, if you were to be taking a string in from a DTO, and as part of your validation logic, you were then constraining it down into this credit card type, you know that once the type enters your domain, you're guaranteed to have the correct data, and you cannot worry about whether it's in the wrong format or it's there or not there. And so you've kind of proved that everything's looking as it should do. That's quite complex. So are there any questions there?
There was one from Nick Callahan actually on, so he was asking what the difference was between using string ampersand digits instead of string single pipe undefined. So it's a question, I guess. I guess it's a confirmation of union types versus intersections.
All right. Yes. Okay. So let's go back to our original thing. So here we said our account was optional. And if you put the question mark and say that it's optional, what TypeScript does is it takes whatever you have here and it says it can either be that or it can be undefined as well. Does that answer the question? Did I understand that correctly? It's a bit of syntactic sugar. So I could have just as, so an equivalent thing would have been to just put this in instead.
Yeah.
Okay.
Yeah, that looks good. And also, Martin Randall has a question, and this is a great one because I've seen the value in tagged types for a while, but I've never really used them. So Martin has a great question. Is there a runtime overhead to using tag hero? Or tag hero?
No, because the type system's erasing, all of that stuff is zapped at compile time. And where you have this kind of validation check here, that's the kind of check that you would have anyway.
Yeah,
and if you
excellent.
didn't have it, you probably should have, and it will force you to do that. Okay, did that make sense? Right, okay, so moving on to the next slide. So far, we've just spoken about types in terms of nouns. They are things. They're like a credit card payment or a something. Types can also refer to verbs as well. So this is quite a good way of modeling your domain. So a domain doesn't just consist of things, it consists of actions that you can do to things. So let's have a look at how that might look. So here you can see that our refund function that we've used all the way through, we've actually given that a type here. So we can say our refund payment is actually this, and actually you can then actually define your domain in terms of nouns and verbs without actually having to write any implementation code at all. You can almost you can use the types in this manner to actually specify your domain. And again, we've before, where we, it's gone weird on me. So before, where we had this function, now that we've kind of pulled that out and made it explicit what this function should take as its input parameters and what it should return, we can see that actually we've got another error here. So if we have a look at this, what is the type system telling us? So the type system is telling us that actually we are getting either a string or we're getting an undefined. So how can that be? How can we get an undefined from here? Well, actually, I've actually snuck in an extra type here. So as part of the specification, at some point, there was also a new requirement for an in-store collection. I put this talk together before lockdown, as you can probably tell. So our type system is now telling us that you can collect it, but we haven't accounted for this in our refund. So if we do a switch on this type, we could actually fall out of this switch, and that would then return an undefined because we hadn't accounted for this. So, so that's why we're getting this compile error. Let's just see what happens if we. And also the other good thing about this is you do get IntelliSense, which is very nice. And you can see now that that just by putting that in, now the compiler is happy again. That's relatively simple in terms of implementation, but the idea of modeling your verbs as well as your nouns is, again, a really powerful concept. So are there any questions about that? Okay. So so that's pretty much a quick kind of run through types and the kind of basic ways that you might use them. So for the last slide, let's have a bit of fun. So I spoke at the beginning about how the type system is actually really sophisticated. It's very sophisticated. It's actually Turing complete. People have written Fibonacci series generators with just using the type system, which, yeah, just because you can do something probably doesn't mean you should, but it does illustrate just how powerful it can be. So things that you can have with that, you've got things like index types, map types, conditional types, and distributed conditional types actually give you the ability to manipulate types themselves, add new properties to a type, remove types. So let's just have a look at an example of where that might be useful. So here's our, going back to basics again, here's our credit card method. So if we are writing tests around this, wouldn't it be nice to have a builder which would function like a normal builder that you might see in an OO sense, but to implement it as a just a normal function. So for example, if we look at these tests, we could build just a basic check method, and it would have the basic our default settings. We could overwrite the sort code. We could overwrite the account code and the sort code. But we want that obviously to be typed, but we don't want to be in a position where we have to manually go to our credit card, our individual types, and re-implement them as optionals. So we've got this kind of construct here, which is going to modify them. So what we've got here is this builder type here. So what I've done is I've created a new type called builder type, and you can give it any type, and you can tell it what the discriminator is. Oh, that's probably something I should have mentioned. Actually, this refers back to the earlier question. When we spoke about the type here and the type here, which would allow you to discriminate between a credit card method and a check method when you put them together as a union type, it's called the discriminator, and that's why a union type is quite often referred to as a discriminated union type. So what we're saying here is we want to have a builder type that's based on our credit card method, but we know that it's a credit card method, so we don't care about having to have the type here. So for example, so these are library types that are built into TypeScript itself. So key of, so this is probably outside the scope of this talk, but essentially this construct here will return a new type which is exactly the same as the previous type, except for it will be missing this type K here, which is our type of literal type. So this, what it in effect does, is it gives us a new type that's just missing this definition here. In addition, what partial does is, and you can see its definition here, partial goes through every attribute in your type and rewrites it to add undefined to the end as well. So what this will in effect give you, our builder credit card method will return a type of credit card number only that's optional, which means that we can have this kind of construct, but still have our builder where we can set these default values. This is incredibly powerful by being able to manipulate your type system, but still make sure that that everything kind of hangs together and it's still type safe. are there any questions on that? I realized that's quite kind of different to how you might traditionally use a type system. Okay. So in conclusion, so this was all about how we would use types in TypeScript and how by using those types with a bit of domain modeling, we can make illegal states unrepresentable. And that follows on to a proof is deterministic, not probabilistic, which is my slightly tongue-in-cheek dig at tests. By modeling our domain in this respect, we've got a provably correct system rather than, or as well as using tests, which will give us a high probability that our system is correct, but they can't be used to give us a proof. So that is my talk. Are there any questions overall? Okay. So in that case, thank you for your time, everyone. I hope that kind of hung together and made sense. It's a bit of a strange experience talking into the void. Oh, and I should mention as well, we're also recruiting. That's at Zulka. We're a polyglot.org, so choose your poison. But also, if you have mobile experience, we'd also really like to hear from you as well. So, okay, thank you very much, and I shall hand you back to James.